Welcome to Chapter 2, all about multiplication. We're going to start pretty easy with multiplication comparisons. Let's get started. The first thing that we're going to look at is this statement right here. It says 12 is 3 times as many as 4. Now, the first thing that we want to do is break this apart and make sense of this statement. So what we're going to do is we're going to cross out some of these words and make it look a lot more like a multiplication problem. Whenever we see the word is, it means equals. Is equals. 3 times 4 is 12. Is represents equals. Our next part that we're going to cross out and change is times as many as. We're going to cross that whole thing out, and all we're going to do is put a multiplication sign above it. We can go ahead and we can rewrite this problem as 12 is or equals 3 times as many as 4. And that's it. 12 is 3 times as many as 4. Now, we want to use a model to represent 12 equals 3 times 4. And we need to figure out, well, what does that mean? This expression means that if we have 4s 3 times, so 3 4s, that we are going to equal, when we add that up, 12. That's it. 12 equals 3 times 4. That means we have 3 4s. Let's look at this statement again, but flipped around so its words look a little different. 12 is 4 times as many as 3. Again, all we're going to do is go into our problem and cross things out and make it easier to read. When we see is, that means equals. Times as many as is a multiplication sign. So we could rewrite this problem. 12 equals 4 times 3. Now we're going to draw this in a model to represent it the same way that we did the last one, but this one's going to look a little different. 12 is 4 times as many as 3 is like saying we have 3 4 times. 3 4 times. We could put a little addition sign between that as well. We know that multiplication is just repeated addition. So 12 equals 4 times 3 is the same as adding 3 times. Just like back here, 12 equals 3 times 4 is the same as adding 4 3 times. Just repeated addition. Now, those are two different ways that we could write this problem. Here are all 4 ways we can write this problem. 12 equals 3 times 4. 12 equals 4 times 3. 3 times 4 equals 12, and 4 times 3 equals 12. It doesn't matter which number is in front. No matter what, we're going to get 12 as our product. Now, the property that goes along with this, our ability to turn these, is called the commutative property. Now, the commutative property works for both multiplication and addition, as long as it's just one sign. So if we had any multiplication problem, 39 times 105. That problem and 105 times 39 would give me the same product. Same with addition. If I had 5 plus 6, that equals 11, and so does 6 plus 5. They're both going to equal 11. The commutative property tells us so. So when we're given a problem like this and we need to simplify it, make sense of it, we can do that super easily by just crossing some words out. Times as many as is a multiplication sign, is an equal sign, and if we rewrite this problem, 7 times 6 is equal to 42. Just that simple. We don't even have to do any math. All we have to do is cross some numbers out. I want you to give one a try. Here we have a word problem, and we need to figure out, what are we going to do with this word problem? What are they trying to have us solve? We're going to use the same principles that we just used of crossing some of these words out to simplify this problem for us. Let's go ahead and start by just reading our problem. Carly has 9 pennies. Jack has 4 times as many pennies as Carly. How many pennies does Jack have? The same thing occurs here. Just like any of our word problems, we're going to underline our important information. And we're going to underline our question first. So how many pennies does Jack have? That's what I'm trying to solve. Now, it tells us that Carly has 9 pennies. Congratulations, Carly, you have 9 pennies. Jack has 4 times as many pennies as Carly. Let's go ahead and cross some of these words out. When we see times as many as, we can cross that out and we can put a multiplication sign there. Now, when we look at that, it helps us a little bit, but not all the way. So let's go and look at that sentence one more time. Jack has 4 times as many pennies as Carly. Well, how many pennies does Carly have? We underline that information so it can help us. It's right there. So I'm going to cross out Carly and I'm going to put a 9. Now I have a really simple multiplication problem for me to solve. Jack has 4 times 9 pennies. That's how many pennies he has. 4 times 9. So in order for us to figure out how many pennies Jack has, if Carly has 9, and Jack has 4 times that amount, we can multiply 9 times 4 to give us the number that Jack has. We're going to use N to represent Jack. Sometimes we're going to use letters to represent our unknown amounts. Now, we could use J if we wanted for Jack's name. It doesn't matter what letter we use, as long as we're using one of the letters in the alphabet to help us represent our missing value. So, how many pennies does Jack have? 9 times 4 is equal to 36. So Jack has 36 pennies. Let's take a look at another one like this, and we're going to do some more crossing out. There are 8 students in art club. There are 3 times as many students in chorus. How many students are in chorus? I want to know how many are in chorus. There are 8 students in art club. There are 3 times as many students in chorus. 3 times as many students, multiplication sign. Now I need to figure out what I'm going to be multiplying. 3 times what? Well, the art club is the only other option, and there were 8 students there. So 3 times 8 is what I'm going to be looking at. So if I have a little graph to help me, it would look something like this. I have 8 students in art, and each of these boxes represents the same value. So I have 8 3 times to represent chorus. And this is my missing value. I can put a C here for chorus. I could put an N. You could put the first letter of your name. It doesn't matter what letter we choose as long as we choose a letter as our variable. That's our unknown amount that we're trying to find. Now we want to figure out how many students are in chorus. So we're going to set up a simple multiplication problem to find out. We have 8 3 times. 8 times 3 is going to give us the number of students in chorus, which is equal to 24 students. And that's it. That's all there is to it. We can look at our word problems and we can cross out some information to help us. Whenever we see the word is, that becomes an equal sign. Whenever we see times as many as, that's a multiplication sign. All of these things can help us simplify our word problems and make them easier for us to solve. We're going to look at one more problem, and I want you to give this problem a shot before I work it out. So here's our problem. Jim has 32 markers. This is 8 times as many markers as Mark. How many markers does Mark have? Go ahead and try this problem. See if you can get to an answer. Now, that principle of crossing these words out really helps at this stage. When we see that word is, this is 8 times as many as Mark, we can cross out is and put our equal sign. What is 8 times as many as Mark? 32 markers. So Jim has 32 markers, and that's equal to 8 times as many as Mark. And when I read that times as many as, that's where my multiplication sign is. So 32 is equals 8 times Mark. How many markers does Mark have? I need to think about my multiplication facts. I have 8 times something is equal to 32. 8 times what is equal to 32? 8 times 4. So my answer is Mark has 4 markers. Poor Mark. I hope that Jim shares some markers with him. Now, you see how this problem, even though it was kind of the reverse of the other problems that we've worked so far, can be solved very easily when we break it down, cross some of those words out, change them out with some signs, and rewrite our problem in a nice and simple way. Mark has 4 markers. That's our lesson for today. See you tomorrow.